For our next example, we're once again going to revisit the gradebook case study. And for this version of the case study, we'll once again use a determine class average method to calculate the class average for a set of students on an exam. The difference in this version of the example is that we're going to use Sentinel controlled repetition rather than counter controlled repetition because we're not going to know the number of students in advance. Now, just to show you, the gradebook test class is identical to the previous version that you saw in the preceding example. Once again, we will create the gradebook object, we will tell it to display its message, and then we will tell it to determine the class average. And as I mentioned in the preceding example, in later versions of the case study, we'll physically store the grades in the gradebook. In this example, everything that has to do with calculating the class average occurs in the determine class average method. So let's go ahead and take a look at that method in the gradebook class. That's the only thing that's changed in this version of the example, so I'm going to go straight to that method. Now, once again, I chose in this code to declare the variables right at the beginning of the method, but as I've mentioned previously now, we certainly could have declared the variables as they get used in the program. So the total and the grade counter on lines 33 and 34, we could have declared them there as well. Same thing for grade at line 39, and even for the average variable down here at line 57. Now, you'll notice we declared the average as a double, but we're maintaining everything else as integers. One of the things we'll introduce in this example is how to convert a integer value to a floating point value for the purpose of a calculation. So because we're using Sentinel controlled repetition and don't know in advance how many grades are going to be input, we need to write our loop a little bit differently. Let me go ahead and run the program first so you can see it in action. And as you can see, once again, we display the message first. Then we have the user enter some grades. So let me go ahead and enter a few grades here. And let's say we just have 3 students in this class. Notice, by the way, I'm prompting the user for the Sentinel value to terminate the input. And we used -1 here because -1 is not a valid grade value. Valid grades are 0 through 100. We're assuming the user enters them correctly, by the way. And -1 being a non-valid grade is a good Sentinel value to help us determine when to terminate the input. So I'll go ahead and hit enter, and you can see what the total of the grades was. And in this case, notice the class average is being displayed with 87.67 as the average. So we're getting a floating point proper calculation for the class average in this example. Now, if you take a look at the code, once again, we're going to set the total to 0 because we don't have any grades yet. But notice that we've set grade counter to 0 as well. And the reason for that is the very first thing the user enters could be the Sentinel value. So if I go ahead and run this one more time and I type -1 immediately, notice that it simply tells me no grades were entered. So we have that test in this program to determine whether there were any grades before we calculate the average. Now, the main difference between the Sentinel controlled loop and the counter controlled loop is that for the Sentinel controlled loop, we need to input the first grade before we reach the loop so that we can test whether that value was the Sentinel. And if it's not the Sentinel, then we process the grade and we read the next value inside the body of the loop. So we prompt the user for the grade, read in the grade and convert it to an integer, storing it in the variable grade. Then, as long as that value is not equal to -1, the Sentinel value, we add the grade to the total, add 1 to the grade counter because we now have a valid grade that was just entered. Then we prompt the user for the next value and read it in. And of course, when you reach the closing curly brace of the loop, that brings us back to line 42 to test whether the new grade that was just entered is not equal to -1. If it's still a valid grade, we process it again, otherwise the loop terminates. And that gets us to an if-else statement that checks first to see whether the grade counter is not equal to 0. If there are no grades, then we're going to jump right away down to the else part of this if-else statement and simply display no grades were entered. Notice that my else does not have curly braces around its one statement body, but many programmers prefer to always put those curly braces in. So for example, I certainly could have implemented the curly braces as you see here. Now let me go back to the way the code was. If the condition is true that grade counter is not equal to 0, that means there was at least one grade, and for that purpose we're going to calculate the class average here at line 57. And you'll notice that we've used a cast operator, as it's called, to convert the value of total to type double for the purpose of this calculation. Now it doesn't actually modify the variable total, it makes a copy of total's value, which is an integer, and converts that copy to a double, so that I now have a double value divided by an integer value. And anytime you have a mixed type arithmetic expression in C, C++, Java, C#, Objective-C, the compiler is automatically going to promote one of the values to the same type as the other value so that the calculation can be performed. And in the case of a double and an int, the int always gets promoted to type double. So what I wind up with here is a double divided by a double, giving me a double average value. Now, if I did not have this cast operator here, then it would still be an integer calculation on the right side of this assignment operator, because total is an int and grade counter is an int. And without that double cast operator, that means that the result of that division will be an integer, and then it will be converted to a double to store in the average. So if I wind up with an average such as 87.67 and I don't use the double cast operator here, then 87 would be the average value in that case, and you would still get that integer truncation. At line 60 and 61, we then display the total of all the grades entered and how many grades there were. And finally, at line 62, we display the class average using the format 0:F. 0 is the placeholder position number, and :F indicates that we want a floating point number, and by default, the floating point number will be displayed with 2 digits to the right of the decimal point.